Hey everyone, welcome to the third session of Application of CS, and today I'm just going to be going over homework 1, giving you guys the solution and kind of running through a little bit of Git just so that you guys know how to pull and push the homework in later sessions. So this is just going to be a quick little video, and if you have any questions just ask because I'll be going through the homework pretty quickly. So the first thing I want you guys to do is cd into your Applications of CS folder again. Alright, perfect. And if you had it properly set up from the last time that we did the GitHub lecture, you should see your ACS underscore username folder in there. So let's just go directly into it. And if you do ls, you should have nothing in here, but I do. Don't really worry about that too much because, or don't worry about that at all, sorry, because we're going to grab that right now. So if you do a git remote v, you should see that the skeleton should be already set up from last time. And if you go into it, git, let's pull from the skeleton in order to get the code that I already have in here. So git pull skeleton master, and your code should be right in there. I have attached a Git reference sheet for you guys to use on the file. And let me just reset my internet because I think it's broken. But I attached a Git reference sheet if you want to look right on here, and you guys should be able to reference that and understand everything on this since the last lecture. So just take a look at that if you're confused. So let me just do it again. Perfect. So mine's already up to date. Yours will have it'll say completed unpackaging files, and you should see homework 1 and homework 2 here. So if you haven't worked on the homework yet, just open that homework in Sublime by going into your folder, and let's go with Sublime Text. Bam. And your homework file should be here. Alright, I'm going to be showing you the solution. So I'm going to go into Solutions and pull that up here. Perfect. So for solutions, I have this up. And I'm just going to go through this really quickly. If you have any questions, really just please ask because it's a surprisingly complicated problem. So let's make a comment section here. Okay, perfect. So first things first, let's understand what I did here. So the first thing I did was I checked for edge cases. So first I understood the problem, okay? So the first thing you want to do is say, okay, well, what does the problem really say? A to the power of b using only addition basically means I'm going to have to break down what exponents really are and break them down into the very basic building blocks, which is addition. So the next thing I did was, okay, well, I need to check for edge cases. So are there any scenarios in which a to the power of b is not going to come out with something that I expect? And the answer is yes, and that is when b is equal to 0. When b is equal to 0, no matter what the exponent is, the answer is going to be 1. So the first thing you do is you make this statement at the beginning to catch that edge case. All right. The next thing I did was implement the actual a to the power of b using only addition code. So what I understood from this problem is I'm going to need 2 loops. Okay, the first loop is to deal with multiplication. If you break down a to the power of b, it's a loop of multiplication. So 2 to the power of 3 is just 2 times 2 times 2, right? So the first thing I understand is I need 2 loops. Okay, the first loop being, first loop is, so let's say a to the power of b is equal to a times a times a dot 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 b times. Alright, and the next thing I need to do for the second loop is, well, I can't use multiplication, so let's break that down even further, and let's say, what is a times a? And a times a is equal to a plus a plus a, blah blah blah, a times. Alright, so now that I have my 2 basic loops set up, I need to understand well, how do you connect these loops together? So how does a to the power of b translate into this a plus a plus a plus a stuff? All right, and let's figure out how that's done by just simply connecting them. So a times a, oops. Let's do an example. Let's do 3 to the power of 4 is equal to 3 times 3. Oops, got too used to typing a's. 3 times 3 times 3. Oh gosh. Times 3. Okay, perfect. All right. And now what does that equal? Okay, now let's break it down step by step. So what is 3 times 3? Let's do the first parentheses. And that is what? 3 times 3. Let's do it and break down into different steps. So a is 3 times 3. And that is equal to 3 plus 3 plus 3, correct? All right, now this is the tricky part. When you're doing addition, you can just loop it straight, you know, a plus a plus a plus a, you know, whatever amount of times. But when you're doing multiplication using addition, it's different because 3 times 3 times 3 is not the same thing as 3 plus 3 plus 3 plus 3 3 times. So this does not equal this 3 times 3 times 3 times 3 because this is literally, you know, oh, sorry, okay. Take 2. So now let's look at this. Let's now break this down. So let's start with the first element, 3 times 3. Okay, and let's say, or let's break it down into 3 things. Let's do this one. Let's do this one, and then finally we're going to do this one. Okay, so let's do the first one. 3 times 3. And what does that equal? 3 plus 3 plus 3. Simple. Okay, so now is the tricky part. So what do you think the second element is? It's not, let's do a times 3. Okay, so this is equal to the entire value of this plus the entire value of this plus the entire value of this. Oops. And the tricky part is, well, you can't just loop something, do a very simple loop of 3 plus 3 plus 3, and then just keep, you know, adding 3 onto it. You have to take the result of doing the first multiplication and increment that and loop that result 3 times. All right, and the next one, C, you have to increment the result of B 3 times. So this is 27, this is 9, and this becomes 81. All right, you don't want to run into the trap where you loop 3 times 3 4 times, which is going to get you 3 times 3 times 3 times 4, which is not what you want. You want 3 times 3 times 3 times 3, and you'll see what I mean in a sec. So now let's go back to this problem. Okay, so break down the code. For C1 in range 0 to B, all right, so that is doing this first loop, this outer loop. All right, now I need to break down these individual multiplications, so I do an inner loop to deal with my multiplication. So first thing I do is I wrote this for loop inside to do something a times. Okay, so as you can see, whenever I'm doing something here, I add these values, I do it a times. So essentially what I'm doing here is this is the previous result of, you know, let's say this is, actually I'm going to change this. I'm going to say this because this matches up with my explanation better. All right, I'll update the solution in a second. But so what I'm doing here is, okay, I'm first adding the result A. So the first time the result is equal to 3. And I'm looping that 3 times and accumulating that result in temp. So let's go through the first time. So let's see. The first time I go through this loop, all right, B is equal to, or C1 is equal to 0, and C2 is equal to 0. All right. results is equal to, actually, take 2. So now that I want to go into this code, I'm going to change this code a little bit just so it matches up with my explanation a little bit better. It does exactly the same thing, but it's just more intuitive this way. Let's start with this inner loop right here. Okay, so this inner loop is going to be what deals with my multiplication. As you can see, this does something b times, or b minus 1 times, okay, and this does something a times. So I know that this matches up with my addition function. So let's start with temp is equal, so this counter is equal to 0, all right? This is what I'm going to be accumulating the result of my addition in, okay? And my addition, I'm just going to be adding the results of my previous addition statement and incrementing that 3 times, so or a times. So if you look at this, if a the first time is 3 times 3, I'm adding the result, which is set to a, 3 times. So 3 plus 3 plus 3, and throwing that in temp. So now temp is equal to 9, and the result is equal to temp. So the result is now equal to 9. Okay. Now that I finished this entire loop, I'm going on to the next b, which is, or next C1 increment, which is C1 is equal to 1. And then I'm doing this all over again with the new result. Okay. So now we're moving on to this step. So now that I know that the result is a, so let's make this 9 so you guys can see a little more clearly. Now the result is 9. I'm doing 9 plus 9 plus 9, all right, and to get 27, okay? So now temp is 27 and result is 27. So as you can see, every single time I'm looping through here, I'm recycling temp and making it equal to 0, but I'm accumulating result so that the result eventually will equal to the desired result, okay? So now let's go back to explaining why I changed this to a and this to b minus 1. So originally when this was equal to 1, what I actually was doing this. So let's say, substep. I was actually adding accumulating plus 1 plus 2. Okay, so I was getting 3, and I was doing 3 is equal to result, and then doing this, and then doing this, and then doing this, which is it works, but it's not as intuitive as just starting out with the 3 and then doing this 3 times. So originally my first one I had it doing 4 times, building up the 3, then building up 3 plus 3 plus 3, then 9 plus 9 plus 9, then 27 plus 27 plus 27, and doing, so that's a loop of 4 different I guess functions or actions, and this time I'm just cutting out the first function and doing it b minus 1 time. So that's the basic gist of this. Kind of confusing, but just make sure that you understand this whole looping thing, because loops are very, very important in the future. This one's a little bit more complicated than you need to get, but in the future it's going to be really helpful to understand this whole nested structure, and I think it's a very, very good question to start out with, to kind of wrap your head around what CS is really like and how to think like a CS person, because what CS people do is they break down very large problems, such as a to the power of b, into very small problems, and then kind of build it like Lego blocks. So something I forgot to explain to you is the concept of abstraction. We're going to wrap up soon, I promise, just to give me a minute of your time. And abstraction is the concept of taking code and kind of interpreting it as an action or a block of code rather than each individual part. So let's take a look at this code and how I can make it more abstract and easier to understand. So let's make a new comment block down here, and let's see if I can make this into English. So the first thing I'm going to do is, well, check edge case and to see if b is equal to 0, and if it does, return 1, and that catches edge case of power of 0 and returns 1 if that is true. Okay, so that's very easy to understand. So the next thing I did was I don't need to worry about, result equals a, I have counters, I have loops, I have b minus 1, a minus 1, what variables are what. I'm just going to simply say that, okay, well, the next thing I do is I loop b times b minus 1 times, okay, and the inside I do multiplies result by a, okay? So it loops a times and it just adds the result of a, and inside here I do adds a to result, okay? So this is abstracted to this, and this is abstracted to this because this has a loop on it, so I can just erase that. Alright, and so this entire piece of code is simplified into multiplies the results by a, okay? And when I loop b minus 1 times, I set result equal to temp, so what I'm doing here, this entire thing is actually doing accumulates result times result b minus 1 times. All right. So if I abstract this whole thing, I can just say, well, inside this function, I know that this multiplies or this adds result to itself a times. Okay. So you don't have to look at this code as, oh, all of these different variables. You look at it as, okay, what exactly does it do? Then you move outside, you abstract it a little bit further, and in the end you can understand that, okay, well, now that I understand what each block of code does, I can just throw it into anywhere that I need something to do this block. So that's why functions exist in different code lengths. Functions are objects, which is basically you're writing blocks of code that can be abstracted as the name of the function. So I don't need to worry about what this function does or what it contains. I just need to know that it calculates a to the power of b using only addition, so that if I ever needed that in any other portion of my code, I can just throw this function in and assume that it's going to do what it's going to do. Except in computer science, if you want to look it up and understand a little bit further, that's really cool as well. But don't worry, you'll get it eventually. All you need to understand is that coding is basically like building different Lego blocks. And if you're having trouble kind of reading the code, just try to do this abstract method of saying, okay, I understand this part, and let's read it into English and just kind of understand the code that way. So that's all for today. Hopefully you understood everything that's going on. I'm going to push this homework to the solutions, and I want you guys to actually implement this, or if you have any interesting solutions, I want you guys to push that to your ACS underscore Felix says 86, or sorry, ACS underscore username folder on GitHub, and I can look over it as well. Otherwise, this is going to be the solutions. So exactly how you pulled from the skeleton, go cd into your solutions file and then pull from solutions, and you get it as well. Actually, let me show you that right now. I'm going to do cd backwards and go into my solutions folder, and you can just do git pull solutions and master. Oops, sorry. We got to set up a git remote first. Git remote. Let's see what the repo name is. Oops, sorry. Git remote add. There we go. Oh, git remote add. Oh, I apologize. Solutions, and then that. So now if you do git remote v, your solution should be there, and just do a git pull solutions master. Perfect. So now you have all the solutions CD out of it. Let's go into your ACS and go into homework 1, or actually you don't need to. So if you do a git status, you can see that your homework 1 file has been changed. Do a git add homework1, homework1.py. And if you do a git status again, you can see that it turned green and said it's being tracked. Homework1 submission, and then do a git push origin master, and this should send it right over. Perfect. So now your git is submitted, and if you put your git repository in the spreadsheet that I asked, then I will be able to check it, and you will be good to go. So I just submitted mine. If you want to pull from the solutions, you can do it just as I showed you before. And yep, so that's the start of coding, and next time we're going to be doing some more cool stuff, and soon we'll be moving on to JavaScript, because I kind of want to get you started on that to create more projects. So hopefully you learned a lot, and I'll see you next time. Bye.